Welcome to the Techxpert Series, where we unpack pressing questions and emerging possibilities in African AI. Today, we're talking about something that is nearly second nature to many Africans, but almost impossible for machines to understand: code switching. From the street corners to boardrooms, many of us switch between English to native languages and back, sometimes in one sentence. However, this linguistic fluidity poses a serious challenge to machines as at now. With me here, I have Moses Daudu, our in-house AI engineer working on our multilingual LLM here at Awarri. And together, we'll be cracking this code on why it's hard for machines to understand code switching and any proven strategies there are to make this a reality. Hello, Moses.
Hi, Bamishe.
How are you doing?
Okay.
All right, great. So now let's dive in. The first question is, what does code switching look like in the African context? And how common is it, across demographics and regions?
Code switching is really common, especially among bilingual speakers. And the way it looks like is basically when someone is speaking a language, let's say you're speaking English, and then you add chips of Pidgin, or someone is speaking Yoruba, and then they add bits of English in it. So it's really, really common, especially amongst bilingual speakers. And in Nigeria, it's common amongst the Yoruba, the people that speak Yoruba.
Oh, really?
English, yeah. And also it's really common amongst South Africans as well. So on Twitter, you would most likely see this thing where, a South African is saying something and then they
switch into their language.
So it's really, really common. Yeah.
All right, thank you for that. So now, why do you think that code switching is often overlooked or misunderstood in mainstream NLP research?
Well, I'll say that it boils down to the architecture of the models we use. So the current existing models that we use, they have an encoder and decoder layer. So the first thing that happens is the model tries to extract the features from the audio, then it encodes that, and then it tries to decode that, targeting a specific language. So when you speak multiple languages, it's not able to understand that, because whenever it's trying to decode the audio, it's looking at a specific target language. And within that target language, there are specific tokens that have already been trained with the model. So when you
put in another language,
yeah,
like foreign to
exactly,
it.
It's like something that it doesn't know. So it's not able to understand that. It will try to transcribe that, but most likely it will come to result to
an error.
Yeah.
All right, so now diving into more technicalities, what makes code switch input difficult for language models to process or understand?
All right, yeah, thank you for that. So the way most models are trained by just one particular language, even though we have architectures that can take in multiple languages at once, but usually they're trained just one language. So during that process, we need to convert the audio text to tokens. So when you start saying that in different language, it's likely that those tokens were not present in the training stage of the model. Just like I said previously, the way the model understands the way we speak is that it tries to extract the features from the audio first, then it tries to encode that, and then it decodes that, pointing that to a specific target language. So if you start speaking a different language completely that the model does not know, it will find it very difficult to be able to transcribe that properly. Now, like I said before, it will most likely give a transcription, but most likely that transcription will not be correct.
And are there ways that encoder-decoder architecture can be improved to ensure that the anomalies, or this, let me not call it anomalies, that this difficulty in linear understanding can be worked on?
Well, yes. For us to bypass this, we definitely need to come up with a new architecture. Either that, or find ways to maybe during the training stage include all the tokens, and then further fine-tune on a specific language. So there are ways, but it's a really challenging aspect in the NLP world, especially in our own side of the world. It's a really challenging issue. But I would say the first one is, if you can try to build a new architecture that is able to account for that, that's one. But then again, that would be really challenging, because the current existing state of the art models are already so good. Whisper and Proofsofect, they're really so good, and this is the way they operate. So building something different would be very expensive and obviously be time consuming. And the second approach to do this would be, if you can get a vast amount of data that contains all the languages, then use that in the training process of just one single model, and then use that as a single transcription base for fine-tuning further to single languages. So it's possible that would improve the process.
So speaking about the input and output behavior of code switch data, what are some of the observable behaviors of this code switch input? Is it hallucination? Is it missing context? Is it, incorrect information?
Well, generally it's incorrect information, but also, doesn't have enough context. So I believe that in any language, like if you're an English speaker, you can try to, write out, the spoken word for any language. If someone is trying to speak Yoruba and you don't know Yoruba, but you only understand English, to a large extent, you can try to write that down, right?
Okay.
Most likely it's not going to be correct.
Yeah.
So that's the same thing that the model tries to do. So if the model was only trained on, let's say Yoruba, for instance, and you now start to introduce Igbo, so it will, take that as a Yoruba speaker and try to interpret that in Yoruba way. So it all boils down to the tokenization process, like I said before. So that is what we are currently seeing. If someone is maybe working with an English model, and then they start speaking Yoruba, the model will actually try to, like if I say Bawoni now, the model will actually try
the
to
closest English words
and put that down. But like I said before, most definitely that would be incorrect.
Okay. All right. So moving further on that, do current multilingual models see code switched inputs as a valid language pattern, or do they see it as an anomaly?
Well, I think they currently see it as a valid, pattern, but they just try to transcribe it in the best way that they know.
Okay.
So there's currently, I don't think there's currently any way for, if you look at the current state of the app models from Gemini and OpenAI, if you actually engage those models and then you try to code switch, they will still try to interpret what you said in the language that you started out with. So it's a really big challenge.
Okay. So it's a valid language pattern, but just not as accurate as it needs to be.
Yeah, exactly.
All right. So you talked about how getting a large volume of data that is diverse can help with this. But how does the current data set contribute to that? And are there vast enough data sets that can, even in a meaningful volume, that can contribute to enhancing models for example switching?
Yeah, so I would say that the current existing data sets that we have out there are lacking in various areas. So if you look at some of those data sets, they're targeting specific areas. For instance, one of them could be targeting conversational domain, maybe people having conversation. Another one is targeting, something different. But I believe the next generation of benchmark data set, which is what we are doing at Awarri, is to be able to look at, all these domains that will be necessary for, speech, and then be able to build data sets around those domains. And in Awarri, we're doing something called horizontal and vertical variations. So we are collecting data across multiple domains horizontally, and then even within those domains, we're also collecting data vertically as well. So across, speed, across frequency rates and things like that. So I believe currently the current existing data set that we have out there are not ideal enough for us to build a very robust speech recognition model. But what we are doing at Awarri is to be able to, bypass that hurdle and build the next generation of benchmark data sets.
Wow, that's really amazing. So now, if you had to imagine an ideal data set that could help models to code switch fluently, what would it look like?
Okay, so it's actually in two ways. So it's on the model part and on the data set part.
Okay.
So right now we have really good data sets, right? But the main challenge is the model. So I think on the data set side, just like I said before, being able to identify various domains that are involved in speech. So people, reading different things, conversations, somebody, giving a speech, just those kind of things, being able to collect those kind of data sets.
In different contexts.
Yeah. And then training a model collecting data sets across the languages, by the way. And then training a model on all those data. So you're training a model on all the languages. You're not going to be segmenting the tokenizers. Everything falls under, one tokenizer file. And then after that, using that to downstream and train on one language, I think that would go a long way to, having a model that can code switch. Also, on the model side, it is something that will be quite challenging. But generally, just having a model that doesn't go through the traditional means of, it still goes through the process of extracting the features, because that's really important. Then encoding that. When in the process of decoding it, maybe decoding it to multiple languages at once, rather than decoding it to just one language at a time. Obviously, it's better said than done. It's easier said than done. But I think that would go a long way in solving this issue.
Okay, it's a possibility.
Yeah.
All right, so thinking of possibilities now, could synthetic data generation or community data sourcing help to solve this issue?
Yeah, definitely. I've always been an advocate for synthetic data usage because I believe that a time will come where we basically exhausted all the available data sets that we have, and creating new data sets in traditional way is really expensive. But the main challenge with synthetic data is we have to find a way to ensure that what we are generating is actually ideal to what we need. What we are generating is actually correct.
So there needs to be lots of quality assurance.
Exactly, quality assurance. Yeah, because you understand that models hallucinate, and based on the fact that they're probabilistic in nature, so they always predict the next token and the next token and the next token after that based on probability. So there's always a likelihood of them making mistakes. So the only issue that I have with synthetic data generation is quality assurance. Yeah, and also here at Awarri, we also do synthetic data generation, but we have the numbers, we have the people, the annotators to be able to validate what we generate. So yeah, I believe synthetic data will be very.
How about community data sourcing?
Community data sourcing is also good as well, but it falls back to what I said initially. That most of the data sets that we have right now, even community-based, they are usually targeted at a specific domain. And take for instance now, we are building a speech recognition model that is really good and everything. If you go through the conventional community approach, it will only be based on a specific political zone, or it will only be based on a specific region. We don't want that to be included in our model. It's kind of introduce things like bias, things like that. So I think the community approach is good.
How about we have like different communities?
Yes, that's what I was going to say. Yeah, so having different communities is also like a very, very good thing, but also it can be very expensive
as well. Right. So I love that answer. Now let's think future forward. Right. What would it look like for a language model to be truly code switch aware, to not just understand the switch, but the why behind the switch?
Yeah, for this to happen, right, the model will need to, obviously be trained with all those tokens, like I said before. And it's sort of like difficult to pinpoint how that would look like right now. But generally speaking, the model will be token aware, will be aware of all the tokens that will be needed for each language. Obviously, that's going to be really difficult because of the amount of languages that we have. But I believe targeting just a couple of languages, maybe, building a model that can be able to code switch between English and Yoruba.
That's in the Nigerian
context would be a very good start before we now move to adding multiple languages to that. Yeah. So I believe that's the way that will look like.
Okay, so I like that you've been very realistic with your responses, making mention of possibilities, but also not leaving out the limitations currently. So I'd like to know, what are the small steps that African builders, linguists, and developers can take to start addressing these issues in order to see a successfully code switch aware model in the future, even if it takes years to build?
Okay, so I believe the first step that we can take is to leverage platforms like Angizi to collect code switch data. So data where people are code switching, people are speaking between different languages. We could target, like I said before, target specific languages first before we then scale that to multiple other languages. So leveraging platforms like Angizi will be able to allow us to collect those code switch data and then eventually use that to train the model. And obviously with that, we'll be able to build state-of-the-art models that can easily code switch from one language to another. And I believe that would be a really good step in the right direction.
It's amazing. Now, do you think that code switching is important for the models of the future?
Definitely. For the models of the past or the models of the current, they were built on the Western knowledge, and most of them don't really code switch really. But I believe if you want to add Africa to this,
the world AI map.
Exactly, to world AI map. We definitely need to consider code switching because it's really common amongst us, it's common amongst the people, and we need that to reflect in the model's ability as well.
That's amazing. So to wrap up this conversation, this has been very insightful, I must say, Moses. To wrap this up, would you say that Africa is uniquely positioned to champion this charge for code switch aware models, and why?
Yeah, definitely. I think companies like Awarri, good work that Awarri is doing in the African land space, will definitely champion this. Most existing companies out there, they don't really, I don't want to say they don't care about Africa, but we're not their target market. So I believe that what Awarri is doing would actually, create a ripple down effect for the next generation of models that are coming out there to be able to build models that represent us better.
So Awarri is uniquely positioned because we're building AI for us by us.
Exactly, yeah.
So it's like identity, it's owning our heritage.
Exactly. So AI that correctly represents the people.
That's amazing. Thank you very much, Moses,
You're welcome.
for this conversation. And do hope that we see a more advanced technological future, especially with Africa in mind and Africa at the forefront of AI.
Yeah, thank you very much.
See you in the next episode of
See you.
Techxpert Series.
Bye.